Now there's another option from pd7974, and that's as follows, as you can see here. And this is expressed as an AV, not an AV-CV factor. It's taken account of the coefficient in the formula itself, so it comes out as an AV factor. This is a formula here, where your AV is your area of your ventilator. This is a geometric area. Your M smoke is your mass flow rate of smoke in kilograms a second. Your T is your average smoke temperature of the layer. Your CV is your vent coefficient. You've got G, which is acceleration due to gravity, which is normally taken as 9.81 metres a second. Your D is your smoke layer depth. You've got your density of ambient air in kilograms per metre cubed. You've got your theta value, which is your increase in temperature in Kelvin. You've got your TO, which is your ambient temperature of the air, which is normally taken as 293 degrees Kelvin. And then you've got your AI, which is your inlet area in square metres, and you've got your CI, which is your inlet coefficient. They are the variables in this formula. So let's do an example with this model then. Let's determine the total area of ventilators required for a smoke reservoir with the following parameters. Your mass flow rate of smoke is taken as 43 kilograms a second. Your density of air is taken as 1.177 kilograms per metre cubed. Your temperature of your smoke layer is taken as 417 degrees Kelvin. Acceleration due to gravity is 9.81 metres a second squared. Your smoke layer depth is 3.56 metres. Your theta value, your temperature increase is 124 degrees Kelvin. And your ambient air temperature is 293 degrees Kelvin. The total area for the inlet vents is 20 square metres, and they have a coefficient of 0.6. If you put these variables into this formula here, you should have got an AV factor of 21.42 square metres. So we need at least 21.42 square metres of area, geometric area, based on a 60% efficient ventilator. That's what you should have got. Let's do another example. Determine the area of ventilation for a reservoir with the following parameters. Your mass flow rate of smoke is given as 55 kilograms a second. The density of air is 1.177 kilograms per metre cubed. The temperature of your smoke layer is 383 degrees Kelvin. Acceleration due to gravity is given as 9.81 metres a second squared. Your smoke layer depth is 5.68 metres, and your theta value is 90 degrees Kelvin. And your ambient air temperature is taken as 293 degrees Kelvin. There's 24.5 metres of air inlet available, and the inlet vents have a coefficient of 0.6. Now, if you put those into this formula, what you should have got is an AV of 22.2 square metres. That's what you should have got. Now that covers the examples. Now what we want you to do now is go through the exercises in your workbook. So work through the exercises, and when you've done them, click on the links below and you can view the model answers.